Cool. This is the L2 Interop working group, call number 10. Shared the agenda in the chat. We have three main agenda items today, starting off with a presentation from Bioeconomy on enabling gasless one-click Ethereum. After that, we have an update on the Kohaku wallet, which is a prototype wallet for Interop and privacy being worked on by the EF and Wonderland team. And then last up, we have a discussion on based rollups and how they potentially fit into the general sort of interop acceleration work happening more broadly in the Ethereum ecosystem. And we have a few special guests coming who will present their thoughts on based rollups. Cool. So let's kick things off with Mislav, whenever you're ready.
Yeah, I'm ready. Hello, everyone. I'm just going to do the classic. Can you see my screen?
Yep.
Yeah. All right. Great. So got a lot of ground to cover, so won't be saying too much. I'm Mislav. I'm the VP of product at Bioeconomy. Been working as an Ethereum EVM developer, researcher, evangelist since 2016. So been quite a while. And this is something I'm extremely proud to present. It's the culmination of basically 2 years of my life, and together with Bioeconomy and other people who have contributed on this, is basically, we call them verifiable multi-chain scripts. These are scripts which are injected into call data and executed on-chain, but I'll show you much more about them. But what they enable is gasless one-click Ethereum and a few other things, but this is what we're going to focus on today. So the idea here is that the Web3 UX and DevX still aren't that great. We've made enormous strides since I joined in 2016. The difference is now night and day, and things are going in a great direction. But signing multiple transactions across chains is still kind of a nightmare. So you go, approve plus execute, but then you wait for the bridge to complete. Then you do something on the destination. If there are multiple chains that are, the destinations, then it becomes even more complex. Writing smart contracts for simple logic is overkill. I am a firm believer that we are writing way too many smart contracts, and that a lot of these things need to be able to be written in other languages and then injected into blockchain through a scripting engine, which I'll explain. And gas management and transaction batching is still kind of complex. And for batching, I think it's kind of primitive, because you can only batch static call data, which doesn't really respond to changes with on-chain conditions. The vision number one: make every action a single signature. No matter how many function calls, chains, or what span of time it spans, it should always be a single signature. Vision number two: make gas a thing of the past, even for EOA users, and I would say even for non-7702 users. We need to really get the entire Ethereum ecosystem forgetting about manual gas management by users. And enable division number three, and this one might be the most ambitious, is enable non-contract developers to write 90% of the application code for any Ethereum application or EVM application. And so I'm going to show you a quick demo of what I mean by gasless one-click Ethereum. So you can see here I'm in the worst case situation for an EVM user. I've got 10 USDC on Arbitrum, and I want to supply to a Morpho finance pool, which is on Base, and I need to supply WETH. So I've got the wrong token on the wrong chain. And to make matters worse, I don't have gas on Arbitrum. I don't have gas on Base. And to make matters even worse, I'm using a regular EOA account that hasn't been upgraded to 7702. And so what you can see here now, that we are able, wait, I'm on the local machine. So we are able essentially to execute these multi-chain flows gaslessly and orchestrate them across chains. So what you can see now is I have signed an ERC20 permit message that moves my funds to an orchestrator contract. This is a smart account owned by the user. The orchestration across multiple chains is happening on that orchestration smart account owned by the user. And the end results, after everything is done, are transferred to the user's EOA. I can go to Morpho and see now that I should have, sometimes it takes a while to update, but we can check it on chain, that I have actually executed 2 transactions on 2 chains with a single gasless signature by the user. And if I go to base scan, I can see that I did actually receive RE7 WETH on base. So this is the type of things that we can achieve with multi-chain scripting and the framework that we have built. Here's my presentation. So I'm kind of trying to get a lot across in a little bit of time. So what we do is we change the model from transactions into what we call super transactions. Super transactions are essentially multiple function calls across multiple chains condensed into a single hash by the usage of a Merkle tree. Basically, we hash all the instructions, put them into a Merkle tree, and then the user signs the root hash of the Merkle tree, which approves all the function calls across all chains. This is how a super transaction looks. So you have payment instructions on any chain. And yeah, very important, this supports cross-chain gas. You can pay for gas in ERC20 tokens or sponsor gas across chains. So pay for gas on Optimism with like USDC on Polygon or Arbitrum or wherever. These are like Optimism, Arbitrum, Polygon instructions. You hash all of them. You get this super transaction hash. When the user signs that hash, they approve all of the actions across all of the chains. Asynchronous ordering, obviously, if you're going across chains, sometimes you're going to have asynchronous execution where the next transaction needs to wait for the previous one. We do this by the usage of preconditions. So for example, in this case, the transaction on the destination chain didn't execute until it received a predefined minimum amount of funds. But this was not done by the relayer. This was not done by the bundler or the off-chain infrastructure. This was actually enforced in the encoded call data that was encoded when we were building this super transaction. So the destination chain transaction cannot even execute on chain until all preconditions are met. This is done so that the entire system is trustless and permissionless. This is essentially how the ordering works. You simulate the transaction until it stops reverting. And again, all the preconditions are encoded into the call data itself. So it will keep reverting until like everything is met. And then the relayer, once the simulation stops reverting, it executes the next transaction in order. Composable batch execute. So one very important thing is if you do a swap, then supply, you cannot know ahead of time how much you'll actually get from the swap, right? There is MEV, there is slippage, there is unknown runtime conditions. What we can do in this scripting is intercept any function call, and instead of having a predefined parameter like supply 100 USDC, you can say, hey, supply however much was received from the previous transaction, dynamically inject it on chain into the parameter during runtime. And this is basically how it's done. You say like encode composable function data, lending protocol, and instead of putting the amount as a fixed amount, you say, give me the runtime ERC20 balance of some token on some account and inject it as a parameter into the next function call. These super transactions interplay really nicely with EIP 7702 and ERC 7715. Basically, you don't really want these scripts to execute directly on your main account or your EOA because they can access all of the funds on that account where they are executing. So you want to sandbox the account for security. What you saw in the demo was us actually approving a fixed amount of tokens to this orchestrator account to execute basically these transactions. So it's always sandboxed. The script can never access more than you actually gave it. Right now, we are using like normal ERC20 approve or ERC20 permit signatures. But when EIP 7702 comes into play and becomes more prevalent, we can use ERC 7715 to request funds from the user's account to the orchestrator account and then execute there. This is extremely, extremely secure, and it uses basically the browser-based model of like sandboxing requests from applications and showing to the user the maximum amount of funds that any application can access at any time. And now this is like very esoteric. We're still not there in our building, but we already have a plan for this. These scripts can be general purpose, Turing complete. Basically, they can include if-else conditionals, loops, schedulings, early halt, and everything. So anything basically that you can build with like a contract, you would be able to build with these scripts. They're not a match for everything that a smart contract is a match for, but you could like store something to transient storage from the previous instruction, read it in the next instruction, and then do all of this. So it's important it's all encoded in the call data. So this is very important for me to emphasize. There is nothing happening off-chain in a trusted environment. There is nothing that you have to trust beyond the blockchain code itself. The relayer only posts this specially encoded call data on chain, but then all validation of like conditionals, loops, halts, preconditions, everything is done by a smart contract on chain. And we are now working on a TypeScript scripting DSL, where basically it's a very easy way to write multi-chain scripts which are verified on chain and execute there, but like you write it in a very natural sort of like domain specific language, which is a library in TypeScript. We call it abstract.js. If you want to play around with this is in production today. We already have clients using this. Go to docs.byconomy.io, get in touch with me. I am OX Shaman. This is not 0x, this is OX. On Telegram and on Twitter, I am OX_Shaman. And yeah, I have to mention some of our core technical contributors who made this happen. And yeah, this is the end of my presentation. I hope I was on time.
That was perfect. Thank you so much. Any quick questions for Mislav?
I had a quick question. The first transaction, like you said, there's no gas. Like, where did the gas come from? The user didn't have gas. How did you get it started?
So you get it started here. In this case, this was a token that supports ERC20 permit. So you signed an off-chain message which permitted the orchestrator account to spend the funds from the EOA. And then within that ERC20 permit message, we actually inject the hash of the root Merkle tree, so that at the same time you sign both the permission for tokens to be spent and you approve all of the instructions. So this is kind of a, let's call it a hack until we have ERC7715 fully available. So we can do it with like ERC20 permit tokens. If the token didn't support ERC20 permit, we can do it by actually appending the super transaction hash to the call data of a normal ERC20 approve call. Then you just need to have enough gas for like approve. You don't need the gas for the entire instruction set, just for the approval of the token to the orchestrator account. But even then, like some of our clients, they will like just pre-fund that small amount of gas because it's a deterministic amount. You always just need for one approve call, and that's it.
Okay, thanks.
I have a quick one. By the way, this is amazing. Congrats. My question is on the example you did with the view balance function. Is it possible to also use the return value of, for example, a swap, a non-view function?
Yes, you can inject anything. So basically, you can call any function call, or you can get the return value of any previous instruction. So this is now working in a sort of single instruction context. But if you look in how we usually do it in our examples, we will always say, for example, execute composable batch calls. There will always be multiple instructions. So for example, approve, then swap, then approve, then deposit. And in those, you will always have like an argument that's done like this. But then you can also, in this instruction, you can store the output of this instruction into transient storage, and then use that transient storage as a parameter in the next function call.
Perfect. That makes sense. Thanks. And a follow-up question, since you were mentioning transient storage, this assumes you are atomically executing all the instructions on the chain of execution, right?
Yes, single chain execution is atomic. So all the instructions on a single chain are batched into an atomic bundle. But if you go across chains, then it becomes non-atomic. But we do have like a cleanup system where you can define cleanup transactions in case any of these destination chain transactions fails. How do you handle this gracefully and fallback? But yes, to answer your question, everything on the same chain is atomic.
Perfect. Thank you.
Okay, great. Thanks again for the presentation, Mislav.
Yeah, cheers. Thank you for having me.
Absolutely.
Sorry, maybe one quick question if I can still. What is the integration mode if you wanted to support like a new bridge or a new chain? Is that something that like the Byconomy team has to do? Is it something that like people can do themselves? Like, well,
you can do it yourself. Basically, the idea is that this just orchestrates call data, right? It just does multiple function calls across multiple chains composably. As long as a bridge can be triggered by calling an on-chain function, like a contract function call, you can integrate it yourself. You don't need to ask us for integration.
Cool. And what about like a new chain? Like I guess like right, like if I want to like I don't know, like launch Nam chain, I want to have this part experience of Nam chain. Like, can I do that myself as well? Do I have to talk to you guys about getting like your like? I assume like you will have specific relayers that you will run to make this happen, or?
So we don't run relayers. We have a network of relayers. Basically, it's a permissionless network. You can join it by like getting behind the Pathfinder. So there's now like a lot of like network architecture that we do there with the relayers. I purposefully kind of skipped that for brevity. But yeah, in principle, it's permissionless as long as you like stake tokens, because one thing that I also didn't mention, you stake tokens to guarantee liveness of execution. So there's also a slashing mechanism. If you don't execute like what you promised to execute as a relayer, like you will get slashed, and it's all like censorship resistant and trustless and permissionless. But essentially you stake tokens, and that enables you to join the network, and then you can join on another chain that you want to join, like add another chain. And as far as the contracts go, they are open source contracts that you can permissionlessly deploy on any chain. So they're just like similar to account abstraction contracts. You just need to deploy them on a chain to add support.
Cool, thank you.
And a follow-up on that question, is that network like specific, like a private network, or is it like a is there an ERC for that network to participate as a relayer?
Anyone can join as a relayer for the network. In principle, it's I didn't want to, I promise not to shill like any of the token stuff, but it's in principle you have to just stake the BICO token, and then you can join. It's a public network. It's a permissionless network in principle. Like we're still working on the fully permissionless aspect. To be honest, we kind of have like 10 major node operators now who are running these nodes, but the core idea that we outline in the light paper and the white paper is that we really want like to have hundreds of node operators supporting thousands of chains. Because the interesting thing about this super transaction, if there is like one node that can execute on one chain, but you have a super transaction that touches some chain that node cannot execute, you can split a single super transaction to be executed across multiple nodes. So this means that in a future where we might have like 100, 500, 1,000 Ethereum rollups, you would be able to always find a combination of nodes that can execute your entire path, right? So that was also one of the big design decisions when we were building the protocol.
Okay, thank you.
Okay, great. Well, let's move on. And yeah, if any further discussion or questions, yeah, please message Mislav on Telegram, or we can continue the conversation in the Telegram group as well. Cool. Next up, we have the Kohaku wallet, which I will actually start off with sharing my screen here. 1 second. Okay, hopefully you all can see my screen. 1 second. Cool. Okay, well, I just want to take a couple of minutes here to give a quick overview around Kohaku, what Kohaku is, what our goals are, and just share a little bit briefly around, why we are excited for this work and why we think this can be something valuable in terms of, helping accelerate innovation and just general UX improvements at the wallet layer, which is a critical layer for Interop. I think we all agree over the next 6 to 12 months in particular. So yes, what is Kohaku? It's a prototype wallet for Interop and privacy being developed by the EF and the Wonderland team. Very big shout out and thanks to the Wonderland team, who's doing a lot of the heavy lifting behind the scenes for the Kohaku wallet. And also, yes, big thank you and big shout out to the Ambire team. Kohaku is a fork of Ambire, and Kohaku is Japanese for amber, so that's the name. Goals, like I mentioned, I think sort of prototype emerging standards for interop and privacy and just general acceleration of UX improvements. There are many, very confident, very bullish on a lot of the improvements and innovation happening at the wallet layer over the next 6 or 12 months. But I think it's something that that we really can't over invest in. Again, just such a critical area for Ethereum. So excited to have this as just another effort to be collaborating closely with all of the existing wallet teams on this as well. And yeah, just to emphasize, this is for testnet and prototype purposes only. Really quickly, some of the main features, maybe I'll just go through the V1 here. The V1 is integrating interoperable addresses, aka chain-specific addresses, 7828, 7930. Also integrating the open intents framework and 7683 across to support cross-chain sends. And then the last big piece of the V1 feature here is universal balance views, which is displaying, aggregating same asset balances across chain. So rather than having 7 different flavors of ETH or 6 different flavors of USDC to the user, sort of abstracting that away and showing that as a single asset to the users. I'll drop a link to this and drop a link to the roadmap so you can sort of we can spend more time for anyone that wants to dig more into the roadmap here. I'll just share this really quickly. We have some screens here showing what chain-specific addresses can look like. Here it is in the send screen using something like alice.eth at Arbitrum and the open intents framework. Here's universal balance views, and another example of universal balances here. And I think actually we have TT here from the Wonderland team who's going to maybe spend a bit more time sharing some of the details and going into these screens a bit more. TT, whenever you're ready.
Great. Let me share my screen as well. Give me a second. Okay, hope you can see.
Perfect.
Amazing. Okay, I was going to give you some updates on the interoperable addresses standards, but let me first go through a little bit more details on the wallet itself. So as Josh mentioned, we are working on having an SDK that is protocol and wallet agnostic, and we are integrating it into Kohaku, that is Ambire's fork, as he mentioned, as a prototype. But the idea is to have an amazing developer experience to make it really easy for all wallets to adopt all these features that really improve the user experience. As the first version, we are supporting the standards of interoperable addresses, both the serialization and also the resolution, because I'm going to go into more details later with the Interop addresses standard stuff, but we are moving the GitHub chain list on chain, and it's part of the resolution of the address, which looks something like this, an Interop address. So our SDK already supports the resolution of this right now through the GitHub list, and then it's going to be moved into an on-chain resolution. And it's going to be extremely smooth for wallets to just upgrade the dependency and have that ready on their end for it. And then the other portion that it's supporting on the first version is the cross-chain sense, and we are able to do that through supporting ERC 7683, thanks to all the work from OIF. And the universal balances right now is going to be a display that is going to look something like this, as Josh mentioned, integrating, like aggregating all the flavors. When you have ETH, you don't have to care where you have it. Right now, it's going to show you the aggregated balance, and on the next version that we are start working on, you're going to be able to use this as a chain agnostic asset to do cross-chain transfers, swaps, and everything. And again, this is something we can do thanks to the OIF, because we are also working on supporting multiple inputs into when you open the intent. So we would have like this sort of multiple legs to be resolved atomically on the solver side. Then if the user wants to transfer I don't know, like 2 ETH to Bob at mainnet, and Alice, being our user, has ETH in Arbitrum on Base. Alice is going to care only about the total balance she has of ETH, and then just triggers a transaction to send 2 ETH to Bob without thinking about where the asset is on which chain. Like that will be fully abstracted to the users thanks to the OIF efforts on this. And the solvers that will support this. And then this is like mainly the main improvement we can do on Interop and cross-chain calls. But on top of that, we are also integrating privacy. So privacy, it's a little tricky because you need to know a lot about CK, and then you care about like, what if I leak information? What if somehow it's able like traceability? So we're thinking all that as a system of the UX that we need to provide for the users to have privacy adopted. I will go like really quick through this because I think we don't have much time, but of course, feel free to reach out to us if you have any questions, suggestions, anything. We're more than open to that. The idea is to have privacy natively into the wallet, so you don't have to download something like another app or interact with a different website to get a privacy on chain. This will be done inside the wallet, thanks to our SDK that right now is going to support privacy pools as the privacy protocol. And yeah, we're going to focus mainly on this amazing developer experience. So you will be able to like select the private mode, and you will have already your balance. There are some details and stuff, like for instance, you would need to so if you transfer a specific amount that would be like leaking or allowing some traceabilities, then we have some formula for even amounts to be deposited. There are other like 7702 session key stuff that would allow an automatically top up. So another thing privacy protocols have is like you have this window where it's checked that you're a good actor to then get your funds mixed with others. So here's what you can see here on the pending side, because it's like being reviewed. It's not a KYC process, it's a compliance process of change of your, like the, let's say like a chain analysis of your address. And then once you're into the pool, you can withdraw privately and you can mix within the anonymity set of the volume that is inside it. But okay, I don't want to get too much into the details, but the thing is that there are many things to be considered when you're integrating privacy into a wallet, and we want to abstract all that to the user. For instance, like creating the CK proofs and stuff, like for the user, I refer to the wallets that are going to be integrating all this. And then the user will have this interface where they just use their private ETH, and it's sent like to Alice in a private way. Like Alice cannot know what's Bob, assume this is Bob, what's Bob address for this, okay? So this is like a brief overview of the work we're doing for the first two versions for Interop and privacy to really improve the UX. And then if we do have time, a little note I wanted to do and recap on the standards we're working on. So we have 7930, which is the binary format, and 7828, which is the human readable format of these Interop addresses that mainly look like this. Address at chain. There have been some concerns about compatibility with CAP10 and DID. We have pushed a document that goes into these details. You can check it out at the Ethereum/L2 Interop repo. But the TLDR is that it is compatible, so that's good news. The other thing we're going to work on is to get L2.eth. So through this second level domain, we're going to register the chain list data that currently lives inside the GitHub repo of the EF. It's going to move on-chain for on-chain resolution of having the chain ID that corresponds for that chaining. Right now, we are awaiting some upgrades that are going to happen on ENS. about a new controller and stuff. And we have already proposed the temperature check on the ENS DAO with positive signals. So once the upgrade is done, we are going to create the executable proposal and get L2.eth. And after that, the chains inside the current GitHub repo are going to be moved on chain and get registered for this on chain resolution of chain IDs. I think I went through that pretty quickly, so feel free to let me know if you have any questions, and I'm going to share all the links through the chat.
Thanks so much, Titi. Any questions? Cool. And yeah, get in touch. Anyone that wants to chat more about this or get more involved. And yeah, thanks again to the Wonderland team.
Hi, Josh. Am I quickly all right to ask a question? I'm not sure if there's any process or if you just ask away.
No, go for it.
Yeah, thanks for this, TT. I'm an active participant in the ENS DAO, so I'm aware of this proposal. I was just curious as to, in an ideal world, what your timelines for getting L2 ETH and this proposal pushed through would be, so that I can kind of communicate that within the DAO.
Oh, yeah, if within 2 weeks, for instance.
Okay, I think that might be optimistic. I know that kind of there's always a certain amount of inertia within ENS, and obviously with ECC coming up, that might be pushy. But yeah, everyone's kind of very compelled to move this along, so I will feed that back.
Thank you so much.
Cool. Okay, last up on the agenda, we have based rollups and shared sequencing and how they can best fit into the accelerate interop vision. We have a few based experts here joining us, so yeah, really excited to have them share their own perspectives here. And I think we will have, starting off with Drew from the Fabric team, who can maybe also just give a quick refresher on what are base rollups and how they can fit into everything here and sort of the broader vision for this. So yeah, Drew, whenever you're ready.
Awesome. Yeah, just the classic, is my screen shared on the presentation?
It's perfect. Yep, we see the full screen.
Okay.
If you want to go into slideshow view or keep it like this, but either way.
Yeah, I'll do that. It's a little tougher. That work?
Yep.
Perfect. That's great to meet everyone, and thanks for having us on. I do re-listen to these. I haven't joined any in the past, but yeah, just a quick intro on two efforts that I'm helped driving. One is called Commit Boost, and one is called Fabric. Both are supported by a 501c3 or nonprofit that is focused on mostly outer protocol infrastructure, supporting Ethereum. Commit Boost is a new sidecar that allows validators to do things like issue pre-comps. And Fabric is both a coordination effort, but also trying to get specs into place that will support base rollups and some unification around certain parts of the stack because it makes sense to have it. So that's a bit about that. And yeah, we have grants from across the Ethereum community, including some folks on this call. So really appreciate that. Yeah, so this, there's some debates around interop and based rollups. Josh had this tweet, but I think in my mind, I don't know if Justin's on the call, but I think when based rollups was initially proposed, it was supposed to solve kind of everything. There wasn't a lot of specifics around it, and this is great for memeing, but maybe causes confusion or frustration from some. And I think for us at Fabric, we see based rollups as a very unique application to solve a certain type of interop. And I don't know if everyone on this call believes in synchronous composability. I think everyone here kind of likes async a bit more, but this is, base rollups may not fit within asynchronous composability. It may not be the best solution. I think we're fully admitting that. But where it does make sense is when you want L1, L2 synchronous composability. And we do think that base rollups is the best solution for that. And it fits well within the context of that. And throughout our journey, we've somewhat learned, and I'll talk a bit about this, of maybe some middle ground between giving up fully your sequencing rights and the implications that has for an L2 versus getting like towards being half-based, or what we call this thing called signal boost, which I'll get into. But Josh asked this question on Twitter the other day. Jason, who is the technical lead for Fabric, couldn't join because he had an appointment that he just absolutely couldn't move. And this is kind of his view is the holy grail is L1 to L2 synchronous composability. And there are multiple solutions to get there. We're obviously biased, but we think that to have that holy grail, particularly with the L1, you need a shared sequencer, which there are other solutions for that. But you need tight coordination with the L1 proposer, and then you need to reorg with the L1. And the reason for the L1 proposer, as most is they have the monopoly over the block in Ethereum. And so that's somewhat of our view. Base rollups happens to fit these three requirements. And a bit of a view on maybe like the intent-based ecosystem. This is kind of a bit of a jab, but hopefully in a friendly way, versus what we get with synchronous composability. So sort of say here, I believe we need this intents. We need the chain to act like one chain, but it really isn't one chain. It's a bunch of things strung together. And I'm not saying base rollups isn't also strung together, but at least with synchronous composability, it forces you to be one chain. And personally, just a bit skeptical of all this liquidity, provisioning, things that have to happen. And I come from TradFi, and just would encourage people to read the front of the Wall Street Journal in 2008, 2009 when liquidity did dry up. But I know in the near term, it's a great solution, and maybe in the long term, we can solve some of these things so it can become more robust. But with synchronous composability, the advantages you get is it's just a more general purpose solution. You don't need the liquidity requirements to go across rollups or between the L1 and L2, across base rollups and between the L1 and L2. And then from a developer experience, you really just have to deploy in one place on the L1 or on a base rollup, and anyone can access that. And so it's just streamlined for those developers. This is what a base rollup is. I know I just started it without explaining it. For those who don't know, hopefully most people on this call do. This is Justin Drake's definition. I simply just think of it as data. You have what we call classic rollups. They're running their centralized sequencer. Get rid of that centralized sequencer and replace it with an Ethereum validator or a proposer. And that's somewhat a rough estimate of what a base rollup is. I think the other thing to just dispel and what worked a lot to do is base rollups narrative has been pitched as somewhat of a ETH value accrual, or an Ethereum aligned thing to do, and the only reason you do it is to become aligned. As I've mentioned, I think it actually is a unique thing that Ethereum can provide for the end users of Ethereum. It obviously will help with value accrual to ETH theoretically, but it's more about what Ethereum can do for you, not what you can do for Ethereum. And so that's one of the things we just operate under is what are the unique benefits of using Ethereum as your sequencer, and what can that provide to the end user of Ethereum itself, which in this case are rollup developers. So here are 5 different pitches of why you'd want to become base and the benefits you get from using that. I kind of mentioned this first one, but as a rollup developer or a rollup that becomes based, you don't have to focus so much on getting USDC on your chain, getting an Oracle on your chain, like Chainlink on there. You get to inherit a lot of the infrastructure that's already there and the liquidity on the L1 and other base rollups. So it's pretty accretive in the sense of as more rollups, base rollups launch, you get to benefit from that. Not specifically unique to base rollups, it just is a little more natural because of the way the technology is built. You only have to develop your app in one place, you launch it and everyone can access it. While there are some debates around liveliness and censorship because of things like gateways and pre-confs, there is this general consensus that we're trying to get towards a more permissionless full pipeline. And so, yeah, there are liveliness and censorship resistance benefits you do get from being based. And then mitigate regulatory risk if you're running centralized sequencer. Obviously, the feds know who you are. It's a little harder to shut something down when it's on the L1 validators. And then we have thought a lot about customization of the sequencing. We think this is an underexplored area within the context of base rollups. We have some research and posts coming about this. We've thought about this in the context of commit boost a lot and how validators can sell sequencing rules to end users, mainly in the form of pre-comps, but there's a whole host of other ideas people can have and rollups could request, all the way from, order my block by tip. There's a whole host of things people look at, but we're pushing on the research side of that. So, and then the other thing I think we hear a lot about, and one thing Josh has highlighted is, but when, and hopefully I've given a good pitch on why you should become based or think about it. To be honest, there are two base rollups out there, Tycho and Faucet. They're not, I think both teams would say they're not in their end state. They're still working on things. And so this is how we view the components required for a base rollup. And the check mark means that there's a spec in place or it's already implemented and it's somewhat ready to go. There are changes required by certain teams to get there. The gray is, there's been some work done, but probably needs a little bit more. And then if there isn't a checkbox, it's still not ready. And so, we'll share these slides afterwards. I'm not going to go through each one of these, but a lot of work has been done and tested to help us get to this place. And yeah, the base rollups that are launched, they're using probably some reference implementation of these that we've worked on or other teams have done. There's been quite a few folks that have contributed to all this, or they're taking some shortcuts. That's maybe how they got there already live in production. So yeah, we'll share these slides afterwards so you can take a look. And then we have a link to find out more on somewhat each of these boxes. The other thing we realized is there is apprehension for existing L2s to give up their sequencing rights fully to the L1 proposer. And there's a lot of reasons for this. And we talked with existing L2s, app developers, as well as institutions, just trying to get a sense on what their appetite would be for something like a base rollup and the solution it provides. And one of the things we realize is there a way to get synchronous composability with the L1 without giving up your sequencer? And this is where we came up with this concept of signal boost. And essentially what it is you still run your centralized sequencer, but when you want synchronous composability with the L1, maybe there's a certain use case for that on your rollup, you can actually request that from the L1 proposer through this proposal. So it's more or less like instead of giving up your sequencing right, you're actually closely coordinating with the L1 proposer instead of just fully giving it up. And so kind of on demand, you can ask for the synchronous composability with the L1. You have to pay for it, but you can get it. And this has received quite a bit of reception from teams, and even Tycho has reference implementation now around this and how they're thinking about it. So with that, here's a link to the docs that we have at Fabric. There's dozens of other teams working on base rollups that have contributed in certain ways to this, that have repos as well. So it's not just us, but I'll hopefully I didn't take up too much time. And Josh, thanks for having me and for everyone listening.
Thanks so much, Drew. Yeah, and I want to maybe give the mic over to either Brecht or Dono if either of you want to jump in next. But yeah, the main thing that's on my mind, and we don't have to spend time on this, I guess, question in particular, but it's just sort of, and it's probably a hard one to spend just a few minutes on, but it's around timelines and the actual sort of like making the path a bit more legible for what this looks like to actually for getting these benefits of base rollups, which I think we all agree are real. How do we, but what is the actual sort of pragmatic path to providing this value to end users? And what is this something that we think there is a legible path to making happen in the next 6 to 12 months? Or is there more consensus that this is still a little bit further out? And like, what are the biggest blockers? What are the biggest challenges to making this happen? And I'm not saying this is like, I just, genuinely want to sort of understand like, what is the path here? So yeah, I don't know.
Yeah.
Maybe, go ahead.
It's a little bit unknown. I think like the key blockers, at least from my perspective, one is real-time proving, and that's to get the real synchronous composability in place. Otherwise, it's a little more async. So we all know that that's progressing, but it's still not in a place that we're ready yet for that. And the other thing we've been really focused on is the pre-comps. And so when you become a base rollup today, if you don't have pre-comps, your confirmation time is bounded by the Ethereum slot time. And Ethereum may speed up its slot times, but still like a 6-second slot time isn't what you get on an L2 today. And so there is a degradation of UX. So they have this concept called pre-comps, which is similar to what you do when you swipe your credit card. at Starbucks, you swipe it, you get your coffee. Your money actually doesn't move for a few days, but Visa issues Starbucks a pre-conf saying, hey, the money will make it, so just give them their coffee. And in this instance, it's an L1 proposer providing that pre-conf. We've been working on this for a while. There are teams actually live today. I can't go into details. I'm sure they'll announce things at ECC for pre-confs actually happening in mainnet, not in size, but we, at least on the Fabric side, they're using the specs that we all collectively outlined called the Constraints API mainly, which is just an extension of the current PBS pipeline. There's a couple small API changes required. We're trying to get our own sort of implementation in Hoodie and testing done probably by the end of Q3 is what we're targeting. We need to change the relay. You have to change the builder. You have this thing called the gateway as well, but there are already pre-comps happening on mainnet, and I expect that to take up into year end. And that's probably the other sort of big unlock, not only for the blob cost perspective. We see this in Tycho. I'm not going to go into all the details, but also just, yeah, that improved UX that we have. And then, yeah, I mean, it depends on the roll-up optimism. Like they have to change their inbox contract. We've outlined a spec of how to do that. But will they do that TBD? But then people can take this and sort of run with it. And that would obviously have to be battle tested and things like that. So yeah, I see some potential in the next 6 to 18 months, I would say, for us to see a way more robust setup. And I know I just talked a bunch. One other thing I'll say is solutions like Signal Boost are a great stepping stone, I think, for someone like Tycho or a new rollup to use that, or even Optimism to adjust to have more of a based rollup experience or synchronous composability that we're shooting for.
Got it.
It doesn't require all these changes.
Speaking of Tycho, so I see we have Brecht here. Do you want to maybe jump in and share any thoughts that you have here?
Yeah, I guess. So I guess like the signal boosting is like for existing ROP, Tycho Alicia. So I guess, yeah, I think I'm not sure like what the planning there is, but I guess in the next couple of months we'll be working on that. And then for Tycho Gwyneth, kind of like, yeah, the kind of like, well, I guess the extreme end of like synchronous composability. Hopefully we'll add, like, yeah, we'll have something usable at the end of this year. But for that to happen, there's also like some other stuff, like of course, like the real-time proving. If you don't want to just have like TE proofs, and it seems like, yeah, about the ZK proving, each day there's like a new ZK VM that is like real-time proving, so that looks pretty good to be happening like in the next well, couple of months, hopefully. And then, like, yeah, if you actually want to build like, well, the full like unified Ethereum experience, then I guess you also kind of like have to convince like L1 builders, or at least like gateways, to kind of build L1 blocks and L2 blocks together. And so I think that's kind of like also kind of one of the challenges. But hopefully that will also kind of like make sense for those people to actually do it. Otherwise, I think, yeah, if you just like if you create your own base rollups, then you can make whatever standards you want. So I guess not many problems there. If you actually want to get like other rollups involved in your kind of like interop system, then yeah, I guess there's some standardization also necessary for like blob sharing, for like proof aggregation, for that kind of like stuff. But yeah, hopefully, yeah, I guess the path is kind of clear how we can get like, well, horizontal scalability for like L2s, where every L2 block can actually sell each L1 block, and we can just aggregate proofs for all those based rollups as well. I guess that's the goal. But I guess hopefully, at least this year, we'll have kind of like at least like one rollup system. Hopefully, Tycho Gwyneth kind of like doing this on its own and then working from there.
Thanks, Brick. Dano, anything you want to add from the L2D side?
Yeah, so I don't think it makes sense for me to repeat what like Drew and Brex were saying. Like, I think we all agree on the benefits of base sequencer in terms of credibly neutral shared sequencer, and that this is the only way to get synchronous composability with L1, right? So I see there are some like interesting questions in the chat, so I want to provide a little bit of the other side of the story. So to me, it's very surprising that there is no project live today that I know of that has a shared sequencer. There are a lot of projects with centralized sequencers, and for them it would be very, very easy to do a shared sequencer. One obvious example is rollup as a service providers like Conduit. They service like 25 plus chains, and for them it would be very easy to just have a shared sequencer between all of them. But as far as I know, none of them is working on it, right? So, and like if you really think about it, Or like me personally, I cannot think of very significant use cases that emerge just out of synchronicity. I feel like the most important property that you need is atomicity as well. And we know of big projects working on providing atomicity before real-time proving or before faster than L1. So there are examples like the superchain, there is the AG layer, there is the elastic chain that they're building these very big, difficult infrastructures, very complicated infrastructures to provide atomicity. And what I wanted to say is that I want to invite projects working on base sequencing to look into the AG layer, the superchain and elastic chain specifically as a atomicity providers. And there are some nuances in these solutions. Not all of them work in the same way. For example, the superchain allows to send messages well before proofs are generated. So it's very easy to do synchronous composability between chains in the superchain. The problem is that all the chains in the superchain needs to be standard. The good news is that everyone can deploy their own custom cluster if they want to outside of the official superchain one. Maybe someone can work on trying to build a based rollup OpenStack cluster that is atomic. I know that the elastic chain will provide Interop all the at the time the proofs are generated, but they have super fast prover, so maybe that's good enough. And the AG layer, I don't remember. But the other cool thing that these projects provide is a shared bridge, right? So there have been a lot of discussion regarding shared bridges, why we need shared bridges. You don't want to move assets on L1 because it's expensive. So all these projects already provide shared bridges. For the AG layer and elastic chain, they're already live. The super chain will have one during the next upgrade, I think, at the end of July. And also, like another blocker that I see, another blocker. Another blocker that I see is, of course, that base rollups are forced to publish transactions very often, and is expensive. We've seen projects like we're trying to monitoring the liveness of these projects, and we've seen some of them publishing transaction less often because transaction fees are super competitive between the L2s, and base rollup it's very difficult for base rollup to be competitive. So one thing that would help for sure is if L1 was cheaper. So I also kind of invite people to push for scaling L1 where possible. I think it's more beneficial to scale L1, for example, than having 6-second slot times, because projects today, they want to publish transactions not very often because, again, it's super expensive and transaction fees are very competitive. And yeah, that's all from my side. Oh yeah, sorry. Another thing is, all these projects are not credibly neutral, of course, like the superchain AG layer and the elastic chain. Unfortunately, I think it's impossible to build one that is credibly neutral. All of them would have some sort of governance. So until we have real-time proving, I think this is the best option, unfortunately.
Thanks, Donna. Victor?
Yeah, my question is around the interplay between real-time proving and based rollups and a synchronous composability like this. So basically, we have kind of surprisingly enough, we have multiple ZK VMs now that can within the next, like right now, do real-time proving most of the time, and then within a few months probably we'll be able to do it 99% of the time or more. But we still have cases where we're going to have proofs not get generated in time for any variety of reasons, just simple reliability reasons, for instance. And basically, it's not clear to me how a base rollup or also other solutions that rely on real-time proving react when a proof is not available on time.
I mean, I have thoughts. I could jump in here. So if generally, the way that real-time proving is used in synchronous composability, like in the way that, for example, that Aglair intends to use it, is that you build the block. So like you build the first part of block A, you generate a proof, and then you actually pass this proof into block B. So if you didn't generate the proof in time, then presumably the proposer just like would act like they didn't build the block in time, and that block would be skipped. I mean, there's probably some other ways you could handle it, but that's how I generally see it happening.
Yeah, that's kind of my understanding as well. And it's definitely is a little bit unfortunate that kind of is the reaction, especially because if you want shorter block times, for example, going from 12 seconds to 6 seconds to 2 seconds to, even shorter levels of like latency in terms of the interaction times, you definitely have the case that you definitely have it become the case that, 2-second real-time proving is not really gonna like, maybe you can do it, but like at that point, you're even like achieving greater than 99% reliability is gonna be pretty hard.
Yeah, I mean, I will say technically, an alternative to requiring real-time proving is if the rollups have shared settlement. So like they share the same settlement contract, you can still enforce atomicity that way. And you don't need real-time proving for it. But that's just a really big ask for a lot of rollups to share a settlement contract. But I mean, with things like Aglair, for example, that is essentially what they're doing in a little bit of a different way. Like Aglair doesn't necessarily guarantee atomicity in their current design. I don't know, just pointing it out for like technical correctness. You don't technically need shared or real-time proofs if you have shared settlement.
I appreciate that. Thank you.
I maybe have like a quick question about based rollups. So yes, it's like known that based rollups can be expensive because they have to post to Ethereum very often. But like, where are we, I guess, with like the rollup pre-confirmations the idea where you would have like a pre-confer for a based rollup that would essentially pre-confirm transactions for like 5 minutes, and then they would submit those to the L1. I think that used to be the design, but I'm not sure where the status of that is. Yeah, Ahmad, maybe you know.
Yeah, so on the L2 pre-confirmations, we already it's live on Tyco Hekla, which is the testnet of Tyco. We have 3 participants that have developed L2 preconfs sidecars: Nethermind, Chainbound, and Garca. All 3 participants are pre-confing blocks right now. Every 2 seconds for Tyco Hekla, and only posting once a batch is ready to post. So basically, this improves the UX for the user significantly, where they can get fast confirmations on their transactions, and at the same time it reduces the cost because you can only submit like a batch every couple of slots instead of having to submit a batch or a block every L1 slot or every 2 slots or whatever the time. Of course, there are limitations to what can be aggregated because, for example, currently we have the implementation for preconfs is a whitelisted preconfers, so that the preconfers are basically whitelisted agents addresses, and later on we're working on making this permissionless. So actually the L1 validators can opt in to become preconfers based on their slots and based on being able to force include the preconfed batches. And this is coming I think whitelisted preconf coming to Tyco mainnet should be in 2 or 3 months, and the full permissionless solution should come to mainnet in Q1, Q2 of the next year. Hopefully sooner, but I don't want to be too optimistic. Yeah, but solutions are there, and things are looking better for based rollups in terms of cost and optimizing costs for posting. Yeah, and also like looking at a lot of the grievances that rollups have right now, like for example, the price of posting blobs or the cost of ZK proofs, for example. All of these are being scaled up and sped up by the advancement of technology. You see the advancement of ZK proofs happening in Twitter and all the news about all the speed ups that Sasync, that Zisk, that Risk0 and other teams are working on, OpenVM, etc. I can't mention them all, but a lot of teams are working on these, reducing the cost for posting ZK proofs. And additionally, the L1 core devs are persistent on scaling up the blobs so that enough capacity is there for rollups. Actually, in my opinion, right now, like if we go with the Fusaka peer DAS and the numbers that we're looking into, I think there will be ample amount of blobs, especially with the compression and aggregation that we have and blob sharing research that have been done. There will be ample amount of blob space for rollups to use on the L1. So blobs, costs of blobs on the L1 plus ZK posting on the L1 should be significantly lower in the coming couple of months or quarters.
Awesome. Thanks so much. Cool. Well, we are at time. Thanks all for the good conversation on based and shared sequencing, and we can maybe continue the conversation in the Telegram group. Cool. Thanks all for joining. See you next time.